Good morning. Suppose we have a circuit like this and we have to calculate the currents in the branches of this circuit. Here we call it I4, here I6, I5. So what we are going to do is to do a delta star transformation, and then we calculate the equivalent resistance, and with the current divider we will try to calculate all the currents. So let's modify this circuit by transforming this delta into a star. So what we call this, and here we call it, this one we call it R6 prime, R5 prime, and this is, we call it R4 prime. Let's first calculate this delta star transformation. R5 prime, this is R4 times R6 over the sum of the resistors. R4 prime, this is R6 R5 over the sum, and R6 prime, it's R4 R5 over the sum of the three resistances. Okay, R4 R6, 440 times 50 over the sum, this is 100, so it means 20 ohms. Here R6 R5, 10 times 50 over 100, this is 5 ohms, and here R4 R5, this is 40 times 10 over 100, it's 4 ohms. So it means this one is 5 ohms, 20 ohms, and our 6 prime is 4 ohms. So let's modify this circuit to make it a little bit clear for calculation of the equivalent resistance. So we have R1, we have R2, we have here, we have R5 prime, is that right? R5 prime, here we will have R6 prime, R3 first, R3, and R6 prime, and later we will have R4 prime, is that right? R4 prime, okay, that's it. This is the circuit we have now. Let's take the calculator to calculate. Okay, we have now, you have this circuit, the equivalent resistance is R2 is in parallel with R1, and then we have R3 and R6 prime are in series with this, and then the rest is in parallel with, all of these are in parallel with R5 prime, and the last one we add R4 prime. So this first step, second step, third step, and fourth step. So let's call this one R1 prime, This is R1 times R2 over R1 plus R2. This is 45 times 90 over 135. This is, did I calculate this? Well, I'm not going to look for. Let's do it again. Okay, this is 90 times 45 over 135. This is 30, and R2 prime, it's R1 prime plus R3 plus R6 prime. So this is 30 plus 23, 26 plus R6 prime, which is R6 prime is 4 ohms. So this is 60 ohms. Okay. R2 prime is 60 ohms. R1 prime is 30 ohms. Now, R2 prime is in parallel with R5, so R3 prime, we have R2 prime, which is in parallel with R5 prime. This is 60 times R5 prime is 20 over 80, so it means 20 times 60 over 80. This is 15 ohms. So R3 prime is 15 ohms. Now, the equivalent resistance is R3 prime plus R4 prime, and this is 15 plus 5, and it's 20 ohms. The equivalent resistance is 20 ohms. Now we can calculate. The main current, I, equal to V over equivalent resistance. This is 100 over 20, it's 5 amps. Once we have calculated the main current, which is 5, we use the current divider. Remember the current divider, when we have two resistances in parallel like here we have these are in parallel with this, we can calculate I3, and we can calculate this current, which we will call I5 prime for the moment. So, and once we know I3, we can calculate I2, and we can calculate I1. Okay, let's now calculate the current divider. So the current divider, when we have two resistors in parallel, we can calculate I2 and I1, like here I3 and I5 prime, using the current divider, which says that I1 we can calculate it using this formula times the main current. Same thing with I2, 2 is R1 over R1 plus R2 times the main current. Okay, so it means that here we can calculate I3 and I5 prime using these resistances we called R2 prime, I think. R2 prime, is that the case? First step R1 parallel with R2. This is first step plus R3 plus R6 prime. This is second step. So this is R2 prime. So we can say this is R2 prime. Okay, we can say that I3 is R5 prime over R5 prime plus R2 prime. These are in parallel with this times the main current, which is I. So it means that R5 prime was the value is 20 over 20 plus R2 prime 60 times main current, which is 5. So it meant 20 divided by 80 times 5. This is 125 amp. I3 is 125 amp. It means that I5 prime is equal to 5 minus 125 minus 5, 375 amps. Okay, once we know I3, we can calculate I2 and I3. I2 is R1 over R1 plus R2 times I3. So it means R1, 45 divided by 45 plus 90 times 125. And this is 45 divided by 135 multiplied by 125. This is 0.42 core. So it means that I2 is 442, and we have to minus 125, 0.83. Suppose I1 is 0.83 amps. Okay, we calculated I1, I2, I3. We can calculate I4 by knowing the drop in these two resistors. It means the drop in R4 is equal to the sum of these drops. It means VR5 prime plus VR6 prime. R5 prime, we have this current that flows there, so it means that R5 primes times I5 prime plus current that flows here is I3, R6 prime times I3. So it means that the drop here is R5 prime, which we calculated. R5 prime is 20 times 375 plus R6 prime 4 times I3 times 125. So it means 20 times 375, this is 75 volts plus 125 multiplied by 4, this is 5, so it means it's 80 volt. R4 times I4, we can calculate I4, so it's 80 over R4 is 40, so it means it's 2 amps. We write down I4 is 2 amps. Knowing I4, we can calculate I6, because I5 prime plus is equal to I4 plus I6. I6 is I5 prime minus I4. I4 we calculated. This is 375 minus 2. It means that I6 is 175. Point, of course, here, everywhere, point, amps. And we are left with I5. We have I3 plus I4 in this node. That is equal to I5. So I5 is equal to I3. I3 is 1.25 plus I4. I4 is 2. So it means that I5 is 3.25 amps. We calculated all the currents, and thank you for your attention.